Chemistry is the study of matter and change, so one of the most essential questions you can ask is, what is everything made out of? In this important screencast, we're going to find out how we find that out. How do we find out what everything is made out of? This is the topic of Screencast 3.10. We'll be focusing on the identification of substances. Okay, here's how we're going to identify substances. Basically, lots of machinery can be used, and some of it's very low-tech and can be used almost anywhere. Some of it's very high-tech and very expensive. It's very important to point out that before you identify something, you have to purify it. Identification is essentially useless for a mixture, so be aware that to find out what everything is made out of, first you purify it, then you identify it. Okay, here's some simple methods that are still in use. Every substance, regardless of its amount, has a fixed melting point. It's an intensive property. They also have fixed boiling points. So we can identify it using either a melting point apparatus or a boiling point apparatus. Really, this is just a distillation apparatus with a thermometer that gives you a reading right there of where it boils. Here it gives you usually a little magnifying glass. You look at the crystal. When it boom goes over to a liquid, you read that temperature range and you get either a melting point or a boiling point. In practice, you want them to be as tight as possible, which can be challenging. Anyhow, this is melting point and boiling point, still in use. Another method for identifying substances is to use this device. It ionizes the substance, basically hits it with a flame, and then looks at the component wavelengths to figure out the elements that are present and in what abundance. This leads to an empirical formula. For example, you might end up with an empirical formula of CH4. That means it has 4 hydrogens for every 1 carbon, but it is not its molecular formula necessarily. It could be C2H8. Ooh, I picked a bad example. I don't think C2H8 is possible, but it can be multiple examples of that ratio, so it can give rise to an empirical formula. Here's a device known as infrared spectroscopy. This will take a substance and evaluate its absorption in the infrared range. This is typically where organic, carbon-based substances absorb fairly heavily, and it can identify organic functional groups. We won't have to go there, but in organic chemistry, the classical technique was to know that if this is to the left of 300 inverse 3,000 inverse centimeters, it meant it was aromatic. If it was to the right, it meant it was aliphatic. This range here was fairly complex, but right around here you could see carbonyl groups. Alcohol groups are right here. I'm just trying to remember what I was taught so many years ago. In any event, infrared spectroscopy is a great way to qualitatively figure out what's in your organic substance. Okay, another method is nuclear magnetic resonance spectroscopy, known as NMR. This is based on the same principle as an MRI. It will take a look at how this substance behaves, let's just say magnetically. Let's not go into any more detail than that. But it will give rise to a very powerful series of peaks which can be analyzed, and will give the basic arrangement of these atoms in each molecule. It gives rise to a chemical structure. These other ones don't. So this is a very powerful technique. It tells you basically the bonds between every single atom in the molecule. Usually it's based on a hydrogen, so every hydrogen gives rise to a peak which can be split. We can go into more detail at another time, but nuclear magnetic resonance spectroscopy can give rise to the chemical structure, typically of organic compounds. Another method that you can use is you can use a mass spectrometer, which will analyze the molecular weight of the substance. So for water, for example, it will give a rise at 18 if it could work for water. And it might be an ion, but in any event, this can tell you the molecular weight of the substance, just about any substance. LCMS stands for liquid crystal. Oh, is it not there? Liquid chromatography, mass spectrometry. I'll say it again because it's a mouthful, isn't it? Write it down right there. Liquid chromatography, mass spectrometry. This is the big grand kingpin of all purification identification methods because it's the only one that does both, really. Now, you can take some horrible mixture And first it'll run it through a column, and then it has the wherewithal to take each individual substance from that mixture, for example from blood, and check it out by mass spectrometry. So you could shoot blood into there. None of these other methods work for mixtures. This thing works for a mixture. Shoot in a mixture, it purifies it, and it gives you the molecular weight of each substance. More and more in the future you'll see devices like this. This is Screencast 3.10, and this ends the matter unit.